So now let's, again go back and understand that the problem we are trying to solve. We have this data that I have sourced from the internet. It's a freely available data set, which gives the height of people given there, which has a mapping of the height and weight of individuals, human beings. And now what we want to do is train a machine learning model, which given the height of the people would, tell us what is the expected weight. So this file is stored as a, height-weight.csv on my file system. And that is the first part that I'm doing here. So I have this file, which is a CSV file, and I'm going to read it and load it. So in Python, there is an awesome package called Pandas, which I really recommend for all of you to learn. You should definitely, consider learning Python. But once you start learning Python, one of the best ways to deal with two-dimensional data is Pandas. So it is a very, very good library available, which is what I'm importing here in the second line. And what it does, it can take two-dimensional data and model it as a data frame, right? That is what I'm doing here. I'm asking Pandas to read the CSV file at this path. In my case, it's actually separated with the tab character. If we put a comma here, right? But it is actually separated with the tab character. So I have put the \t character. And I'm asking it to read this file and load it as a data frame. And then once it has loaded, I'm just asking it to show me the first few records. So let's run this. So in a Jupyter notebook, you can just write code in blocks like this and run the highlighted block. So this block is highlighted. And this is what I'm running, right? So it has read that file and it has come up with this, this structure. So essentially, this is very much similar to the structure that we have here, 65, 70, 169, same thing. But it has now read it into a data structure in the program. So once we have this, let's now, start. See, the first thing that I found weird about this data is it's actually in inches and pounds, whereas in India we work in, feet and, and kilograms. So the first thing I'm going to do is to enrich this data. This is a pattern you will see throughout in your machine learning, journey. Many times the input will not be in the formats that you are comfortable with, or, you want to change it. So we will basically create two new columns using Pandas, which is essentially the feet representation of this height and the kilogram representation of this weight. So to do that, that's what I'm doing here. So this is my data frame, which has these three columns now. I'm adding a new column called height for simplicity. And the way I'm doing that is I'm reading the height in inches column, which is this column. And for each of the function in Python, for each of these values in this column, you can use the map functionality to run a function on each of those values. So essentially, I am taking the value and I'm multiplying it with the factor to convert it into feet. And I'm storing that output as a new column called height. So let's see how this works. So now when I do this, I have a new column called height, which is what I defined here. And it is telling me, okay, this many inches means this is the height in feet, right? And it has now become a part of that data structure. So again, Pandas lets you do all of this so simply with one line of code, right? It's the beauty of Python and Pandas working together. The next thing I want to do is, convert. Again, I don't understand pounds very well, being an Indian, so I'm going to convert it into kilograms. And for that, this is the formula. Multiply pounds with this number, and then you get the kilogram representation. And I'm storing that as a weight column. So let's do that. So now we have the height and weight. So this guy is 5.48 feet tall and has a weight of 51.25 kilograms. Right. This guy is 5.65 feet tall and he has 65.45 kilograms of weight. Right. All right. So now what I'm doing is, now I don't care about these two columns because I have my new columns, shiny new columns, which I understand. So that's what I'm doing. I'm creating a new data frame from my existing data frame where I'm just picking these two columns. I actually now don't care about the other columns. Let's run that. All right, so we have a new data frame with just those two columns, and now I'm ready to start building my machine learning model because these are data. This is data I understand now. So that is another, takeaway that I would like you guys to have is when working with data, first get it to a state which you can understand as a human being. Because machines are great with numbers. We are not inherently not every human being is great with numbers. So you have to first get them to a stage where you can relate to this data. I can actually relate to a guy being 5.5 feet and being, 51 kilos of weight. Yeah, to me as a human being, that is now making sense. But the same record here with 65 inches and weighing 112 pounds might make sense to different human beings, people who work in that in pounds and inches, right? So, so first learning was you might not find data in the format that you like, and you should convert it to your format so that you can be confident while doing those analysis. So now the other thing that data frames let us do is essentially find out how many rows do I have in this data set, how much data do I have. You can just do that by measuring the length of the index, which is the first column. So that is essentially 25,000 data points. So we have 25,000 pairs of weight and height in this data frame. Awesome. So now, so far, what have we done? So we have our input data set, which was a CSV file. We essentially asked pandas to read it, right? And then we have, in a way, massaged the data to create new columns which make more sense to us. We have those columns here. And then, we have, now a data frame which is more meaningful to us, right? And now we are going to start building that machine learning model, which we wanted to do all the way. So before doing that, another suggestion is always try to visualize your data, right? Before jumping into, building a machine learning model, all of that, you should be able to visually see how your data looks. So the way I'm going to do that, let me actually run this and then explain what it is. So essentially what I'm trying to do is create a scatter plot of my data, where the x-axis is the height of the person, right? Which is, if you recall, the feature that I'm going to use in my machine learning model. And the dependent variable that I want to predict is the height, the weight in kilograms. What I've done is I have just taken all these 25,000 points and thrown them on this canvas. And this is how it looks. This itself is, giving us some basic understanding. It is telling us that, on an average, generally when height increases, the weight, the top weight for a height is generally, 6 feet, 6.2 is more than the top weight for 6, right? More or less. So it is essentially giving us that as height increases, the weight increases, which is again a known thing, and it is good to see that the data is also reflecting that. Now, coming to now how do we build a machine learning model? So here again, a choice has to be made by the person building this. He has to choose which type of machine learning algorithm to use. So should I use a mathematical based approach? Should I use a tree based approach, right? So in this case, because we have a variable that we have to predict, which is continuous in nature, a weight of different people can be, is a continuous number. Some people might be 50 kilos, 50.5 kilos, others might be 71.2 kilos, somebody might be 95.4 kilos. This is a continuously varying values that we want to predict. So we need a function which can, we want the machine to learn this from this data as a function. And I am choosing for this demo a straight line. A straight line, I want the machine to come up with a function which is a straight line, which represents this data as close as possible. And we will use that function to predict new values. So to do that, this is all the code that you need. This is the beauty. It is not like, there is a lot of code. This is just, you have imported SciPy. This is another package, right? And from that, you are importing the stats module. And once you do that, you just say stats dot do a linear regression. If you remember that these type of mathematical based, where a mathematical function is what the machine learns, is called regression analysis. And we wanted to, in this case, we have chosen a linear regression, a straight line is what we wanted to, come up with. And for it, we are saying, this is the x-axis and this is the y-axis of the data. So data frame of height essentially is we are passing it this column. We are saying this is our feature set. And then we are saying this is our dependent variable. So we are passing it. So this function takes, first the x-axis value, which is your feature, and then it takes the values that you know for the y-axis. And once you do that, it is returning, because this is linear regression, it is returning you a straight line. So it is giving you a slope and an intercept. So straight line can be represented as y equal to mx plus c, where m is the slope and c is the intercept. So it is doing all the crunching, mathematical crunching, it's figuring out variations, figuring out is this line better or this line better or this line better or this line better. It's doing all those variations. and it's finally picking one which it thinks is the best. So let's see what it picked, right? So now it has, given us all these values. We can in fact, just print both of them here and see what it picked. So it has picked a slope of 16.78 and it has picked an intercept of minus 37.45. So essentially the formula it has come up with is equal to the weight equal to m, which is the slope 16.78 times the height plus this constant, right? So the other way to to visualize what it has come up with is whatever straight line it has found, can we just draw it on top of this data to see what has it actually found? Has it found this line or this line or this line, right? So for again that we will use matplotlib, again the same library we use here to scatter plot all this data. We'll use the same thing and we will draw that line. What did it actually predict? So let's continue. Right. So I guess we would have, you guys would have heard up till here, where we used the linear regression model we built with using just these two lines of code, and we could the machine could figure out the straight line which will more or less approximate this data, right? So that is what is happening here. Is we have used the stats package and we have just asked it to do a linear regression on this feature and predict this dependent variable. And once that happens, it gives us the slope and the intercept. Now that we have the slope and the intercept, we can easily define a function which, given the value of x, will do a slope y equal to mx plus c. That's essentially what is happening here. So this is the function that it has learned. This is the model that is built. It has given us the slope and the intercept. And now using that, I am just for each of the input points, I am actually calculating what is the value the machine actually is predicting. And once we do that, this is the line it has chosen, right? So now what we can do with this, now we have this predict function which the machine has learned and is ready for us. So we can ask it to predict what should be the weight of a person who is 5 feet 6 inches, 5.6 feet height. So according to the machine, his height should be this much. We can ask it to predict what should be the the weight of a person who's 4 feet tall, and it can it'll give us a number smaller. So it has learned from data and it has come up with a model. So if you remember, one of the key things we also discussed is how accurate is the model. So one way to measure the accuracy of the model is essentially to calculate a R value, which again is so simple that it has actually happened here. So when you do this linear regression, it is not only giving you the slope and the intercept with which you can come up with the straight line, it is also giving you a measure of the accuracy. So the measure of the accuracy generally should be close to 1. So essentially this measure is given all these points for this value of x. The machine is saying this should be the value. For a person with height 5.4 feet, this should be his weight. But this is all the actual data. This is actually all the variations that exist. So how far away is it from that? So that is the measure of that. And when we see that, in this case, it is a value like 0.25. So essentially a value close to 1 is a very good model, and a value close to 0 is a very bad model. So essentially we have built a machine learning model, but by measuring its accuracy, we have realized that it is not a great model. It is 25% accurate, so to speak, right? So what we have learned essentially here is it's all good to build a model, but you have to then again measure its accuracy, and in this case we are seeing the accuracy is not great at all. All right, so we have built our first machine learning model, and we have used linear regression, which is basically a mathematical function-based learning that the machine is doing. And based on that, we have
now seen how good the model is as well, and we have realized it's not a good model. So a straight line is not a good way to represent this. In fact, just the variation of the data has so much variation, right? So a straight line can never do justice to it. So essentially we chose the wrong model, and that is the reason it did not come up with a good accuracy. One thing to note here is we should always look back and try to understand the problem. Does the weight of a person only depend on his height? Of course not. The weight of a person is way beyond his height, right? There are many other things that go into it. Is he a male or a female? Is what is the age of the person? Which geographic location do they live? Some people live in very cold countries where they might be eating different kinds of food to stay warm, which causes a variation in the weight. So essentially the reason why this model has worked and it has given such a bad output is we are not giving the machine all the other facts. We are only giving it the height, right, and the weight, and we are saying from this you predict, whereas the weight of a person depends on a lot more than actually just the the height of the person. It depends on things like what gender they are, where they live, what is their age, hereditary factors. There are so many other factors. So this is again another challenge and another takeaway that I want you guys to have. In machine learning, it is the machine can learn and make good predictions only when you actually give it all the features that matter. In our case, we gave it only the the only feature that we gave it is the the height of the person, whereas the weight of a person depends on way more than the height. So that is where still human beings are relevant, even if the machines are learning. This is supervised learning, right? So we are teaching it, and if you teach an incomplete story, it'll obviously come up with a model which is not that good, which is exactly what has happened in this case, right? All right, so that is our first example. The other thing to look at it is it's actually not that difficult. It is Python as a language. If you're familiar with Python as a language, most of this is very straightforward. For those of you who are not familiar with Python, I would advocate that you guys surely start learning Python, because it is as I said, a good language to learn. Plus, once you know it, it's not that difficult to do basic machine learning with it. You can get started and actually play around with data and be able to do things like this.